This is a fully worked solution for an exam from Cambridge Assessment International Education. Mathematics Paper 2 Extended Curriculum, May-June 2020, 1 hour 30 minutes. Fully worked out solution. This paper has a total of 70 marks. Our suggested strategy: you have 90 minutes with 70 marks to earn. Use about 1 minute per mark on average. You will then have 20 minutes to spare, which you can use to fill out your name and index number, read the instructions, double check your work at the end, especially the harder questions. If you push yourself harder and spend less time on easier marks, you give yourself more time for harder questions. Question 1. Rectangle A measures 3 centimeters by 8 centimeters. Not drawn to scale. 5 rectangles congruent to A are joined to make a shape. Work out the perimeter of this shape. Reminder, perimeter is the length of the outer boundary only. So we can identify the 8 centimeter side, 8 centimeters here, 8 centimeters, 8, sorry about that, 8. There are 6 lengths which we are sure are 8 centimeters. So we can write here 8 times 6. Then it's the shorter sides of 3 centimeters. We have this, that, 3, 4, 5, 6. So we add 3 times 6 plus this incomplete lengths. This one would be 8 centimeters, but this length here is not being included in the perimeter. So we shall consider this length here from here to here as 5 centimeters, and so will this one be, and this one, and this one, and so we have 5 times 4 as our last. If we key this in the calculator, this is 48, this is 18, and this is 20, and the total is 86 centimeters. Therefore, A is our answer for 2 marks. Find the highest odd number. That is a factor of 60 and of 90. Let us list the factors of each of these numbers, starting with 60, and we start with the top factors. 60 is 1, 30 is another one. If you divide 60 by 2, divide 60 by 3, you get 20. Divide 60 by 4, you get 15. 15 is the first odd factor of 60. So we can leave it there and go to 90, listing all the factors. 90 divided by 1 is 90. 90 can divide into 2 to give us 45. 90 divided by 3 can give us 30. 90 is not divisible by 4, but it is divisible by 5, which gives 18. 90 can be divided by 6 to give us 15. And that is a common factor. So we have 10 as our answer. Number 3, scatter diagrams. Mrs. Salaman gives her class 2 mathematics tests. The scatter diagram shows information about the marks each student scored. Write down the highest mark scored in test 1. We need to look again at the graph. And since we are looking for test 1, we need to read the horizontal scale, and the marks are increasing towards the right. So we need to use our ruler and slide it to the right until we align it to the rightmost mark, which is 66. 66 is our answer. Write down the type of correlation shown in the diagram. Okay, let's look at the graph once more. The points are slanting towards the upper right from the bottom left, and this is a positive gradient, and so our answer will be a positive correlation. Positive, we write. Draw a line of best fit on the diagram. Line of best fit is our approximation of the line that fits the general trend of these points as closely as possible. And this is our estimate. Using your ruler, you can balance the points on either side and ensure the line follows the general trend. Your line could be slightly different, but that is our approximation. Hamish scored 40 marks in the first test. He was absent for test 2. Use your line of best fits to find an estimate for his mark on test 2. Back to the graph, 40 marks was his score. We project it onto the line of best fit and onto test 2, and we get 48 as our estimate. We write 48. Number 4 is on probability. A bag contains blue, red, yellow, and green balls only. A ball is taken from the bag at random. The table shows some information about the probabilities. So all the 4 balls are listed here, and there are no others. So the total probability, if we added these numbers, would be equal to 1. So to find the missing number, we need to do 1 minus 0.15 added to 0.2 plus 0.43. And our answer should be 0.22. That's what we fill in that space. Abdul takes a ball at random and replaces it in the bag. He does this 200 times. Find how many times he expects to take a red ball. Every time he takes a ball, the chance of a red ball is 0.2. So, to do that 200 times would give us 0.2 times 200, which results with 40. Question 5. Sequences and series. The nth term of a sequence is given by 60 minus 8n. Find the largest number in this sequence. First term will be 60 minus 8 times 1, which is just 8, and that will be 52. Second term would be 60 minus 8 times 2, or 16, which gives us 46. And since the terms are getting smaller, our first term is the largest. Here are the first 5 terms of a different sequence. First, second, third, fourth, fifth. What we've just listed are the values of n. We now need to check if the sequence has a common difference between the terms. First term to second term gives us 7. We take a leap of 7, 7. 7. And yes, there is a common difference of 7. So 7n must be part of the general term. But 7n, if we record here 7n, 7 times 1 is 7, 14, 21, 28, and 35. What do we need to do? What adjustment do we need to do to make these terms equal? We need to add 5, and we have the general term for the nth term, 7n plus 5. The diagram shows a trapezium, well, with two parallel sides and two lines which we could call transversals. Work out the value of x. With two parallel lines and a transversal, this pair of angles here is called the C angles, or same side interior angles, or consecutive interior angles, which are always supplementary. Same side interior angles are always supplementary. So if we add these two angles, we get 180. And that's what we shall do to solve for x. 97 minus 3x plus 69 plus 5x is equal to 180 degrees. When you put the numbers together, we get 166. And when we put the x's together, here is 5x minus 3x. So we have plus 2x equals 180. So we can work out 2x should be equal to 14, and therefore x is equal to 7. This number can be expressed as a product of its prime factors. This one too. Here are the prime factors. Now if we take this first number and multiply with the second number, we get this large number here, which we are required to express as a product of its prime factors. So we simply take the prime factors of this number, which is 2 times 3 squared times 13, and multiply with the prime factors of the second number, which are 2 to the power 4 times 3 squared times 13. In our rules of indices, we know that multiplying numbers with the same base requires addition of their indices. So 2 to the power 1 here times 2 to the power 4 should give us 2 to the power 5. Then the 3 squared times the other 3 squared, we get 3 to the power 4, and 13 and 13, 13 and 13 combine to 13 squared. So this here is our answer. Without using a calculator, work out. First, we need to write this as a top-heavy fraction. 3 times 2, 6, plus 1 gives 7 over 3, minus 7 over 8. Then we multiply with outside the brackets. The first thing in such a setup is to evaluate the brackets first. And the LCM of the denominator here is clearly 24 when you multiply both denominators. 8 times 7 is 56, minus 3 times 7, 21. That is brackets, then times 6 over 25. Inside the brackets, we get 35 over 24. Outside the brackets now, 6 over 25. These can divide into each other to give us 1 here, 4 here, 5 here if you divide by 5, 7 here if you divide by 5. So the top numbers remaining are 7 and 1, we multiply them, and the bottom numbers is 4 and 5, we multiply them, and there is our answer, 7/20, and it's already in its simplest form as required. Factorize completely. In this setup, we just need to look for the highest common factor. And considering the numbers, we know 7 can divide into both of them. So 7, and then a is a common factor, not in squared form, but just 7a. And then here we have 3a left, and here we have 4b. So the first one is as simple as that. Part B. Looking at the numbers, they are both divisible by 5. So let's write 5 outside the brackets, and inside the brackets we have 4x squared minus 9x squared. This can be written as 2x squared minus 3x into brackets squared. And you will recall the difference of two squares. These are two squares and we are subtracting them. So we can use the difference of two squares to write inside the brackets as 2x plus, we made a mistake here. This should have been y from the very beginning. This should have been y. So this should be 2x plus 3y, one bracket, and the other bracket should be 2x minus 3y, and that takes care of the difference of two squares. Of course, there is 5 here. So that is a full factorization and the final answer. We just write it here, and we move on. Question 10. Angle properties of a circle. Points A, B, C, D, and E lie on a circle whose center is O. Find the value of x and the value of y. When we look at x is formed from the same chord or arc as this angle, but this angle is at the center and this angle is at the circumference. So x is a half or 1/10, which is 55 degrees. To find y, we need to note that both y and 24 degrees are subtended by the same chord, this one here, and they are both subtended at the circumference. Y therefore must be equal to 24 degrees. Speed time graphs. The diagram shows the speed time graph for 90 seconds of a journey. Calculate the total distance traveled during the 90 seconds. Just remember that on a speed time graph, the distance is found by calculating the area under the graph. It is convenient in this case to subdivide the graph into easier shapes. The lower shape is a rectangle of length 90 and height 6. So when you evaluate that, we get 540. The top shape is a trapezium, and we have one of the lengths is 90. So we have a half 90 plus the top side is 90 minus 30, which is 60, and the height of this is between 6 and 12, so it is 6. Use a calculator to find that this is 450. And the sum of these two is the total distance traveled in the 90 seconds, which should be 990 meters. Record that answer in the appropriate space. Question 12 is about the box and whisker plot. Find the interquartile range of the times taken for the children to complete the puzzle. Remember how to interpret the box and whisker diagram, that is minimum value. Here we have the lower quartile, here we have the median, then the upper quartile, and then the maximum value. Interquartile range is equal to upper quartile minus lower quartile, which is 70 minus 48. That should give us 22 seconds. Part B. The table shows some information about the times in seconds taken from the adults to complete the puzzle. On the grid above, draw the box and whisker plot for the adults. Back to this graph. The first thing to do is to show the main container, the main box, which is between the lower quartile and the upper quartile. Then we need to mark the median as a line in the middle of the box, and then we mark the two extreme points, the minimum and the maximum, and join everything together. You need a ruler to match these values properly to the scale and draw a neat diagram, but that's it for that question. Question 13. C lies on a circle with diameter AD. B lies on AC and E lies on AD such that BE is parallel to CD. AB is 21 centimeters, CD is 18 centimeters, and BE is 13.5 centimeters. Work out the radius of the circle. Let's bear this main question in mind. Given that this AD is the diameter, the radius will be equal to a half the diameter, which is AD, and we should keep this in mind as our last goal. But there is a lot to do before we get here. This question combines circle theorems and trigonometry or Pythagoras theorem, whichever we choose. For this question, we shall use trigonometry. The important circle theorem that we need to remember is that this diameter subtends 90 degrees at the circumference, so we already know angle ACD must be 90 degrees. Angles in a semicircle is an important theorem. And the fact that this angle and this angle are corresponding angles, we know they must be equal to 90 degrees, both of them. 90 degrees. Let us start by focusing on this triangle. Triangle ABE is a right angle. And we can write an expression for tan of alpha. Let's call this angle here alpha. Tan alpha is opposite over adjacent, which is 13.5 over 21. We can evaluate that using our calculator. So we find that alpha is 32.74 degrees. We now focus on this triangle ACD, and AD is the diameter and also the hypotenuse to the right-angled triangle. So we shall write an expression for sine alpha using the bigger triangle. Sine alpha is equal to opposite side divided by the hypotenuse. And using this, then AD will become 18 over sine alpha. We can use our calculator to calculate 18 over the sine 32.74 degrees, and we shall find AD is equal to, this gives us AD is equal to 33.27. Our radius therefore is 16.6 centimeters. We write it in that space. Question 14. This is about composite function. Given fx is 4x plus 3 and gx is 5x minus 4, find the value of p in this expression. The expression is a composite function f of g of x, which can be written alternatively as f of gx. What this means is that the input to the function f shall be g of x. That will be the input to the function of f. So we have f of, instead of gx, we write here 5x minus 4. The meaning of that is that in the place of x in f, we shall not write x for x, and instead of x, we input the output of the function g plus 3. So this x in f is replaced by g of x. And all we now need is to simplify. Expand the brackets first to get 20x minus 16, and then we add 3 outside the brackets. This simplifies to 20x minus 13. This is our fg of x, which is also given up there as 20x plus p. And when we compare these two expressions, we now know that p must be negative 13, which we shall write in the answer box. Part B. Still on functions. Given h of x is equal to 5x minus 1 all over 3, find the inverse of the function h of x. First step, replace h of x with y and write the expression instead as y equals 5x minus 1 over 3. Next, we interchange the positions of x and y, and we get x equals 5y minus 1 over 3, and then we make y the subject of the expression, which requires that we multiply both sides by 3, and we get a new expression, 3x is equal to 5y minus 1. Add 1 to both sides. 3x plus 1 equals 5y. Now all we require is divide both sides by 5 to get y equals 3x plus 1 over 5, which is our inverse function. That's what should go into our answer box. Question 15. P, R, and Q are points on the circle. AB is a tangent to the circle at point Q. QR bisects the angle PQB. Angle BQR, this one here, is equal to x degrees and x is less than 60. Use this information to show that triangle PQR is isosceles triangle. Give a geometrical reason for each step of your work. First is to note that this angle here must be equal to x degrees because this angle is bisected by this line. That means these two angles are equal. So angle PQR is equal to x degrees. Reason: QR bisects angle PQB. That's our reason. Next is to observe that given this tangent and this chord, x is an angle within this segment of the circle. Now the angle in the alternate segment, this remaining segment, which we call the alternate segment, the angle in the alternate segment is always equal to this angle with the tangent. So our second point is angle QPR is also equal to x degrees. The reason being the alternate segment theorem. Now that point is that this triangle PQR has two equal angles which are both less than 60, meaning that that angle cannot be 60, and so the triangle cannot be an equilateral triangle, and so it is isosceles because it has two equal angles. That solves the question. Question 16. M is inversely proportional to the square of p minus 1. When p is equal to 4, m is equal to 5. Find m when p is equal to 6. So we are given m is inversely proportional to p minus 1 squared. We can write this as an equation by putting a constant k over p minus 1 squared. And then we note that m will be equal to 5 when we put p as 4. So 4 minus 1 squared, which tells us that k over 9 is equal to 5. So k must be equal to 45 when we multiply both sides by 9. So k is 45. Find m when p is 6. We replace k with 45 and we replace m with 6 minus 1 squared, which tells us that m is equal to 45 over 5 squared, which can be simplified as 9 over 5 or 1.8. Question 17 is about vectors. M is equal to 5, 7. Find 3m. Multiplying a vector by a scalar simply means 3 times each of the two numbers, 15, 21. That's your answer. Vector VW is equal to 10 minus 24. Find the length or the magnitude of the vector VW. So VW, the magnitude, is found using Pythagoras theorem. 10 squared plus minus 24 squared, and you get the square root. This is 100 plus 576, the square root of all that, which should be 26. So 26 is the answer. We write and move on. Part B. OABC is a parallelogram. OA is equal to vector P. OC is equal to vector Q. E is the point on AB such that AE to EB is 3 to 1. That means we have 3 parts here out of 4 and 1 part out of 4. Find OE in terms of P and Q in its simplest form. Let's start by sketching the line OE. We need that vector. A vector can always be replaced by components that add up to 8. We shall say vector OE is equal to vector OA plus vector AE. But we also need to remember that vector AB as a whole is equal to the vector Q, these two. OC is equal to AB as a vector. So we can say AB, a vector, is equal to Q. So here we can say it is vector P plus 3/4 of this vector AB, which is Q. So our answer in its simplest form is just that. Question 18. Lower and upper bounds. W equals 12, correct to the nearest whole number. Means we can write that 12 can be anywhere between 11.5 to 12.5. Those are the limits of W. H is 4, correct to the nearest whole number. So it can be between 3.5, anywhere between 3.5 to 4.5. Work out the upper bound for the value of P. Because we are using an addition, to get the maximum value or the upper value, we need to use these maximum values for both measurements. So P will be equal to twice the value of W, biggest value of W, 12.5, plus the biggest value of H, which is 4.5. And when you evaluate this, you get 34, because this adds up to 17 times 2, you get 34 as the answer. The diagram shows a cuboid ABCDEFGH of length 20 centimeters and width 5.5 centimeters. The volume of the cuboid is 495 centimeters. Find the angle between the line AG, this one here, from that to that vertex, and the base of the cuboid ABCD. So we need the diagonal to the base, and we need that line AG. We shall be required to find the angle between them. Part of our working will involve this line GC, the height of the cuboid. how do we find the height of the cuboid? The volume, 495, it should be equal to the base length times base width times the height, and we can get the height therefore by doing 495 divided by 20 times 5.5, which is 4.5. So we already know GC is 4.5. To work out the length AC, we need to pull out the base, whose lengths are given 20 and 5.5, because that is the length of DC. And knowing that this angle is a right angle, we use Pythagoras theorem to find that AC is equal to 20 squared plus 5.5 squared. We get the square root equals 20.74. Then we pull out that plane that cuts the cuboid diagonally. So we call that the diagonal plane. It is a vertical plane across the diagonal of the base or the ceiling. We know this length here is 4.5, and we have already worked out the length of AC. Here it is 20.74. Our interest is this angle here. That's what the question asks us to find. So we can use the tan, because this is a right angle also. Tan of theta, let's call it theta, is equal to 4.5 over 20.74. And using our calculator, theta equals 12.2 degrees. Question 20 is about a graphical solution to two equations. One is quadratic, the other one is linear, given by this. Quadratic, linear. The curve y equals x squared minus 2x plus 1 is drawn on a grid. A line is drawn on the same grid. The points of intersection of the line and the curve are used to solve the equation x squared minus 7x plus 5 equals 0. Find the equation of the line in the form y equals mx plus c. At the point of intersection, both values of y given by the two equations must be equal. So x squared minus 2x plus 1 must be equal to whatever mx plus c gives us. Given that this equation has 0 on the right side, we need to ask, what do we need to do to get 0 here? We need to modify this equation here, starting with x squared minus 7x plus 5 means there is something we have done to this equation here, which was initially on the right side. So here it means we have already subtracted 5x and added 4. And if this were to be on the other side, they would have been 5x and 4, so that when they come over, they become minus 5x and 4. So this is what we need to write the equation of the line. It must have been 5x minus 4. Question 21. Expand and simplify 3 brackets, x plus 3, x minus 5, 3x minus 1. 3 brackets require a strategy of dealing with 2 brackets at a time. First 2 brackets can be expanded by writing by writing the first bracket there and writing the second bracket vertically. We get x squared plus 3x. We get minus 5x, and we get minus 15. We need to combine the x's, which is negative 5 plus 3 will give us minus 2x. So the first pair of brackets results with x squared minus 2x minus 15. We bring down the third bracket here, and again we expand. Put the first bracket, this one here, on top, and then we put this one here vertically. This slot here is 3x cubed. Second slot is negative 6x squared. The last place in the top row is negative 45x. Second row, x squared times negative 1 is negative x squared. Negative 2x times negative 1 is plus 2x. And finally, negative 1 times negative 15 is positive 15. Let's put the like terms together. There is only one term with x cubed, two terms with x squared. It's negative 6 and negative 1, so total of negative 7x squared. Terms with only x are negative 45 and plus 2, so negative 43x. And the constant, the only number, is positive 15. That should be our answer. Question 22. Find the area of a regular hexagon with side length 7.4 centimeters. Start by sketching the hexagon. Then we subdivide it by drawing diagonals or across, which brings up 6 equilateral triangles. And if we just deal with one of them and find its area, we shall be able to multiply that area by 6 to get the total area of the hexagon. So let's take one of the triangles aside. We know that angle is 60 degrees, and we know the side is 7.4 and 7.4. Area of one triangle is a half times 7.4 times 7.4 sine 60. The area of one triangle. The area of the whole of this is 6 times all this, a half times 7.4 squared sine 60, which gives us 142 centimeters squared.
Watch the next video. Share with a friend. Subscribe and hit the notification bell icon. Thank you for watching.